For Lab 1, we were tasked to find an object that moves in the same direction at a constant velocity. The purpose of this lab was to use Newton's second law to predict the future motion of an object. This law states that force equals mass times acceleration, which can also be written as final velocity equals the initial velocity plus the net force times the change in time over the mass of the object. Using this fundamental principle, we can predict the motion of a ball rolling at a constant velocity. We would expect that the acceleration of the object is zero, since acceleration is equal to the change in velocity over the change in time. If the velocity does not change, as we would expect to see, acceleration is zero. This is because the sum of the forces acting on the ball is zero. We will now see how well this law will predict the actual motion of a ball using Tracker. After setting the coordinate system so that the ball is rolling in the negative x direction, we can analyze the motion. We see the plot to the right that the ball is moving in a linear motion on the position versus time graph. This straight line suggests a constant velocity, which is what we would expect to see. This represents the observed or actual motion of the ball. Next, we will use VPython to analyze the expected motion of the ball by applying the fundamental principle explained earlier. To use VPython, we must use and apply some physical attributes of the ball. This includes mass, starting position, starting velocity, and the time we want to start the motion. The mass of the ball is 0.266 kilograms. However, this mass is not relevant to the expected motion since, as discussed earlier, the acceleration will be zero due to a zero net force. Next, using the motion on Tracker, we find that the starting position is 0, 0, 0 at time equals 0. Then, to find what the starting velocity at time equals 0 is, we will use velocity equals change in position over change in time. After some simple math using the next data point at negative 0.034 at time equals 0.033 seconds, we can calculate the initial velocity to be negative 1.0300. If we then enter the last piece of information that the net force is zero, we can execute the program. Here we see a graph very similar to that in Tracker program, a linear plot showing the ball traveling in the negative x direction. Although these graphs look very similar, we will go one step further to compare the two in Excel. If we plot the two sources of data, we can see that in fact the expected motion does not match the observed motion. Looking more closely at the video, we actually see that the ball is not moving in a straight line along the x-axis, but in fact drifts slightly to the back of the table towards the end of the video. This could skew the position of the ball in the graph. Perhaps if the ball was directed in a straight line on the table, we would see a more accurate fit of the data to be expected from VPython. However, since both data plots are straight, constant velocity is observed in both cases. Perhaps the initial velocity calculated using Tracker was not an accurate assumption since the ball is started by a push. This could mean that the velocity at the beginning of the video is higher than the constant velocity through the rest of the video. This would offset the expected motion slightly. In conclusion, we saw how Newton's second law can be applied to a real object and how net force of zero affects the motion of an object over time.